These are the notes for Chapter 9, Section 4. We'll begin with a review of our learning targets. I can define and solve for kinetic energy. Kinetic energy is the energy of motion, and it depends on mass and velocity. And the formula that we use for kinetic energy is Ke equals mv squared divided by 2. I can define and solve for gravitational potential energy. Gravitational potential energy is the energy that we transfer to an object when we lift it against gravity and give it the energy of position. The equation for gravitational potential energy is GPE equals weight times height. I can list and explain other forms of energy. There are 7 other forms that we discussed. The first is mechanical energy, which is the total energy of motion and position. To get this, we would add together both potential and kinetic energy. And if you remember, this is the blanket term or the umbrella term. Another form would be thermal energy, which is all the kinetic energy due to random motion of particles that make up an object. This would be things like heat from the sun and cooking. Chemical energy is the energy of a compound that changes as its atoms are rearranged. An example would be food or a battery. Electrical energy is the energy of moving electrons. This is a potential energy until you use it. Okay, so anytime you plug something into an electrical outlet or turn on a light switch. Sound energy is a wave of vibrating particles of air that vibrate your eardrum. Okay, it's important here to note that you have to have those air particles in order to vibrate them. Light energy is produced from the vibrations of electrically charged particles, and the vibrations that transmit light energy do not need matter to travel, so they can travel through space. And we said an example of that would be like the sun. Nuclear energy is the energy that comes from changes in the nucleus of an atom, and if you remember, we said this can be accomplished in 2 ways. The first way is fusion, when 2 nuclei join together, and the second is fission, when one nucleus is split apart. I can explain energy conversion. Energy conversion is a change of one form of energy to another, and remember, any form of energy can change into any other form, and sometimes energy changes into more than one other form. I can define the law of conservation of energy. The law of conservation of energy states that energy cannot be created or destroyed. Every time you convert energy to another form, remember, some of that is converted to thermal energy. And for today, I can give examples of non-renewable resources, and I can explain and give examples of renewable resources. Okay, the notes for Section 9.4, Energy Resources. An energy resource is a natural resource that can be converted into other forms of energy in order to do useful work. The important part of this sentence is useful. We want to have energy that's in a useful form that will allow us to do work with it. Non-renewable resources cannot be replaced or are replaced much more slowly than they are used. Fossil fuels are an important non-renewable resource. Some examples of fossil fuels would be things like petroleum, natural gas, and coal. This picture is showing some non-renewable energy resources and how frequently we use them. These are going to be things like coal, electricity, oil and gas, and nuclear power stations. Fossil fuels are an energy resource that formed from the buried remains of plants and animals that lived millions of years ago. Both the plants and animals stored energy. Plants got energy from the sun. Animal energy came from eating the plants. Burning these fossil fuels releases the stored energy. Some examples of fossil fuels and their uses. Coal is burned to produce steam and run electric generators. Petroleum is used to make products like gasoline, kerosene, wax, and petrochemicals. And natural gas is used in heating systems like at home and in stoves, ovens, and even some vehicles. Another way to generate electrical energy is to use nuclear energy. Similar to fossil fuels, nuclear power plants generate thermal energy that boils water to make steam, which runs a generator. Nuclear energy is generated from the process of nuclear fission. If you remember back to the first section, we talked about nuclear fission, and that is the process in which the nucleus is split apart. And we're going to be splitting apart the nucleus of an atom of elements like uranium. Supply of this element is limited, and the process leaves hazardous materials left over that are difficult to dispose of. We'll talk a little bit more about this in class. Renewable resources are resources that are naturally replaced more quickly than they are used. Some examples would be solar energy, wind, energy from falling water, geothermal energy, and biomass. Again, we'll discuss this more in depth in class. If we're looking at renewable resources versus non-renewable, the biggest difference is the amount of time that it takes in order to generate or regenerate what was used. Biomass is the energy obtained from plants. Plants use and store energy from the sun. We discussed this in section 2. We can burn plants to release this energy. Scientific research is looking into ways to make using biomass a more practical energy source for things like fueling vehicles and heating homes. I'll have a video for you clip to watch in class on this. The last thing I'd like to show you is energy consumption by source. It's going through all the different forms of energy resource that we've talked about just now. Things like biomass, hydropower, geothermal, wind, solar, petroleum, natural gas, coal, uranium, and propane. All the items in the left-hand column are renewable energy resources. As you can see, they account for a very, very small portion of the energy we use. On the other hand, our non-renewable resources account for the vast majority of the energy that we consume.